Okay, let's quickly move on to other movement disorders. A lot of them associated with the basal ganglia. Huntington's disease is a neurodegenerative disorder of the basal ganglia. And the unfortunate part about this disorder is that it has a hereditary component. Huntington's does appear kind of later in life. There are some gradual changes at first in like mental attitude. Patients can become irritable, and naturally so. Then there are movement abnormalities, including increasing clumsiness, some balance problems, chorea, which are involuntary writhing movements. Those become present. Balance problems. I think I said that already. Hyperkinesia is another thing that you see with Huntington's, which are excessive movements, and eventually up to 90% of cells within the striatum specifically die off. It's unfortunate because there's really no cure currently for Huntington's disease, only treatments for it. And it does become fatal. It has fatal pathology that eventually spreads throughout other cortical and subcortical structures. Parkinson's disease is the most common type of basal ganglia disorder. This involves a loss of dopaminergic neurons, specifically in the substantia nigra. Notably, patients exhibit hypokinesia, which is the absence or reduction in the frequency of voluntary movements. Oftentimes, patients will be essentially stuck in a posture and have the inability to change it or move. Moreover, once they start a motion or a movement, they're often slow, which we call bradykinesia. One cool therapeutic technique I'd like to briefly touch on is deep brain stimulation. And this is where an electrode is placed deep inside of the brain and motor control regions of the brain. Sorry about that. It's controlled via an electric pacemaker. So think of deep brain stimulation as someone putting their hand on the volume knob of the radio. It can turn up the volume or induce more neural firing, or it can turn down the volume and inhibit activity. In this regard, it helps the basal ganglia and the movement centers of the brain work properly and more efficiently. I really encourage you to YouTube some examples of this technique with Parkinson's. The results are quite fascinating. It's used a lot for people with advanced Parkinson's or to different patients who don't respond well to drug therapy. In its first decade of use, this procedure was safely performed on over 75,000 patients. The last thing I want to touch on is how experts differ from non-experts. So how is Patrick Mahomes, a master of his craft, quarterback for the KC Chiefs, able to run and throw like he does, while I, on the other hand, can barely get a spiral when I throw a football? Is it just practice? You might have heard of the 10,000 hour rule, where if you practice something truly and efficiently for 10,000 hours, you become an expert in it. Or maybe it's just innate ability. Some people were born with talents and abilities, and others, no matter how hard they try, are just not athletic or not great at whatever their skill may be. Well, studies using diffusion-weighted MRI have found evidence that connectivity in a specific region of the corpus callosum that connects between the left and right supplementary motor areas were different among individuals, so there's variability. With this comes bimanual coordination, and the degree actually of bimanual coordination that a person had was positively correlated with the connectivity between these two regions. So it seems that in experts we do see structural differences in the brain, especially interhemispheric differences. But when there's a correlation, we definitely need to consider causality. So did the experts become good at their craft because of the stronger connectivity? Or did their connectivity strengthen because they engaged in those activities more often? A different experiment kind of got at that question, and it involved jugglers. So they took some people and they made them practice. And after a good amount of practice, the jugglers had increases in gray matter in visual areas in parietal regions associated with movement planning and motion processing. Then they had the jugglers stop practicing, and the gray matter in those same regions shrank, although it did remain kind of above baseline levels. So it scaled with practice. So the answer is, well, it kind of depends. We know that brains are different. There's variability in structural connectivity, interhemispheric differences. So in some people, there will be stronger connections in various areas. So in a sense, some people are born with it. Pat Mahomes, probably a combination of both, born with it, and he works his tail off. But practice can also shape the landscape of the brain. So there's this use it or lose it type of factor. So next time you see Patrick Mahomes in a football game, think about what areas of the brain specifically or what connections might be different in his brain versus a typical non-expert.